My name is Tunde, and today I will be presenting to you the merits and demerits of odd aircraft designs. Many wacky and non standard aircrafts have been built, and even more have been designed, all with unique and interesting concepts, like the Lockheed XFV experimental tail seater prototype escort fighter or the Stipa Caproni experimental Italian aircraft with a barrel-shaped fuselage. Most times, these unconventional ideas have merits and eventually find widespread use in particular applications or for special requirements. Other times, they die at some stage at either the design or fabrication. Some major reasons why most of these unconventional aircraft fail are because of the wetted area, which has a large impact on empty weight and also directly drives parasite drag, trimmed maximum lift coefficient, and added extra weight. This is from the weight attributed to new hardware required to implement an innovation. Today, I will evaluate 5 unconventional aircraft designs, discuss their merits and demerits, discuss how they differ from the design of normal aircrafts. First, I will talk about the flying wing. Secondly, delta or double delta wing. Then, the forward swept wing, multi-fuselage, and asymmetric airplanes. First, the flying wing. The flying wing has neither fuselage nor tail. It stems from the idea that all aircraft really needs is lift and thrust, and that all other components are just extra weight and add drag. Pioneers of the pure flying wing are the Norton brothers, Raymer and Walter, and Jack Northrop. To the right is the HO1X, the Horton's first ever turbojet powered flying wing. It has a wingspan of 52 feet and was capable of 470 knots. This aircraft design used configuration shaping for stealth. To the left is Jack Northrop's YB-49, a jet-powered version of his propeller-driven flying wing. Northrop employed a design philosophy of reducing the lift at the wingtips to nearly zero and twisting the wing to generate most of the lift on the inboard part of the wing. Special design consideration for the flying wings are wing geometry, twist, and airfoil shaping must be carefully considered and analyzed as quickly as possible, and a detailed stability and control analysis should be done as well. Here are some merits and demerits of the flying wing aircraft design. It's aerodynamically sound, has a low structural weight, improved lift over drag ratio, and is fast, can fly fast. Some demerits are longitudinal instability, control, and window placement for the patch for future passenger models. The next aircraft design configuration that I will talk about is the delta and double delta wing. The delta shaped stealth flying wing are shaped like a delta symbol. They are tailless, but some have vertical tail for stability. To the left is the Earl Vulcan, and it has a delta wing. To the right is the Sahab 35 Draken with a double delta wing because of that kink in the middle. Here are some merits and demerits of delta and double delta wing. It has a higher flight speed, low wing structural weight, and high speed drag reduction. On the other side, it has low wing loading and low lift produced at low speed. Next, we have the forward swept wing aircraft design. Pictured here is the scaled composite V Jet 2. Here are some merits and demerits about this aircraft design. It has transonic and supersonic drag reduction, and on the other side, spine-wise flow from sweep causes separation out to the tips, leading to early tip stall. Structural limitation of wing due to bending and balancing issues. The next aircraft design is the multi-fuselage aircraft design. This aircraft design has two or more distinct fuselage components that can be similar or different. Pictured here is the North American Aviation F-82. This aircraft flew the longest ever non-stop distance by a propeller-powered fighter from New York to Hawaii. Here are some merits and demerits about this aircraft design. It's more fuel efficient than one large fuselage by itself, has reduced structural weight, and its merits are its aerodynamic capacity. The final aircraft design configuration is the asymmetrical airplane. Some reason why this design was thought of was because physically symmetric propeller powered aircraft fly in a non-symmetrical flow field. The thrust of a propeller causes a yawing moment during climb. So designers reasoned that since it isn't gonna fly in symmetrically, why do I have to make it look symmetric? Pictured here is a Blohm Voss BV-141. Here are some merits and demerits about this aircraft design. It runs its engines more effectively. If it has two, you can run one at full power and the other at half. It has a reduced frontal area, aggressive maneuvering, and reduced noise, and some demerits are stability criteria. In conclusion, innovative aircraft concepts are worthwhile to study because they introduce us to new and future designs. Not every concept will essentially be a good one. Major areas that aircraft designers of unconventional aircraft need to focus on are weight, wetted area, and trim maximum lift. Thank you.